Hey everyone, welcome back to the HydroBitBox tutorial. This is part 5 in our series. At this point, we should have the power strip where we've connected our wires inside and put our case back together. I did leave off this part just because the end piece, just in case I needed to use it again. I also, for safety, went and took the red insulators from here and from the set, and I've just attached, or not attached, but slid on each insulator to each cord. That way we don't have any accidental electrical things happen. These, once plugged in, if any of the black touch the red, it will complete the circuit. If you're holding it, you would get shocked, and we potentially would, or we would turn on the outlet. Now there has to be something drawing power through for you to get shocked, so I would not worry too much about it, but for safety, again, please go ahead and slide on insulators to each of these wires. Once we have that, we can go ahead and plug it in. I've just plugged it in. It's off camera, but it has been plugged in. And I want to test to make sure that I haven't done anything wrong with 5 and 6. So 5 and 6, if you remember, still maintain power. And how we're going to check that is just flipping the switch here for each of these. So if I flip the switch, I should get my light to come on. And same thing on 5. So 5 and 6 both work. As you can see here, the light is on, light is off. And then if I check my other ones, we should have no lights. Again, because we are taking out that switch and just using our power here. Next thing I found is pretty useful. I'm gonna go ahead and flip these off, all of them off. Pretty useful to do before getting too deep in the weeds is we want to make sure that all of our components are actually working. We don't want to get everything built and then find out our light doesn't work. That would be an easy fix of just getting a new light, but we don't want that to complicate our process. So what I'm gonna do is just to quickly test everything. I'm gonna test my light first, and I have my light here, the cord to my light. I'm gonna plug that into 6, and then I'm gonna turn it on. With this light, it does come with this remote part, and it has light coming on here, and then if I press it, you can see pretty much it's illuminating here, and so I can turn that off. So my light is good. I'm gonna go ahead and unplug that. To test my pumps, I do the same thing. I don't wanna run my pumps when it's dry though, but for this quick test, I'm gonna just plug it, turn it off here, that switch. I'm gonna plug it in, and I'm going to flick it on, flick on the switch to turn it on, listen to see if my pump does make any noise. And then I can turn it back off very quickly. So these pumps are very, 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 very quiet. So you'll have to listen, and it sounds like a hum, just a subtle hum. And when I did it, I did hear a subtle hum. So I'm good on this one. And let me check my other pump. As I mentioned, this pump just came from a different set. You guys will probably have the same pump. My cord looks different because it's a different pump. So I'm gonna plug that one in, check it. Whoop, yep, it's there. And I may have some issues, but we'll see about that later. And unplug that. Last thing I'm gonna need, you should have an AC-DC adapter. Basically, this takes our AC power and switches it to DC. We could plug this into our shield, which plugs into our microbit to test, but luckily we do have this little indicator light on the back. So when it receives power, that should turn green, if I'm not mistaken. I'm gonna plug that in, flick the switch, and, oh, turns blue. Sorry, not green. So that light turns blue. indicates that this does receive power, and all of our electronics seem to work. Our power strip seems to work, and we can go to the next thing. All right, in this section, in this part of the tutorial, we're gonna need our jumper wires, which are these colorful wires here. We're also gonna need our screwdriver set and our relay and shield. Not really needing the microbit quite yet, but we can have it plugged in if we would like to. So in this part, we're gonna be connecting our shield, which is this right here, to our relay, basically allowing us to control and switch on and off power using just our microbit. So with your set, you will have a bunch of different jumper cables, and so the ends are basically where we have a male end where it's pointy and it's a single male end. Then there are some that are female end, which is here, to double female, which is here. And then we got a double female to double female. We have single male to single female, and then single female to single female. I'm going to pick the jumper wires that are the same color as what is shown on our shield. So I've moved this into the camera. We see basically our shield back here has red and yellow and black going. I'm going to be using those colors as much as I can to avoid confusion. Your set may not have that many colors, and that's okay. If it doesn't have as many colors, or if it doesn't have those exact colors, I would just go ahead and pick one, and one that you do have enough of, and basically write down when Justin says red, it means for my wires blue, because that may be what you have the most of. I also see how difficult it's going to be to show the wiring while it's in this plastic box. So I'm going to actually pause real quick, take these out of the box, and then show the wiring that way. So in this portion of the tutorial, I've separated out my jumper wires here. I said I was going to try to be consistent with using yellow, red, and black, so that's what's on our shield. So microbit, this is the shield, and this allows us to access those pins that are there for our microbit. So I also have these yellow, black, and red, though they look a little orange. It will be red. And the ones that I selected to use were female and something on the other side. And you see, so these had female and then male. This is optimal, and I'm gonna use this one for the red one for sure. These will help us be able to plug into our board. And in this step, we're connecting our shield to our relay. So this is the relay. And just for a brief tutorial about it, we have each of these little boxes, and these boxes act as the switches. So these are going to switch on and off our power. Up at the top, these terminals will connect in from our from our shield, from the microbit. And then we have, it says DC minus, DC plus. This is where we're going to put in the power and ground for our things. On the sides here, these little jumpers coordinate whether it's going to be changing or switching based on low voltage or high voltage, and so we won't really need to tamper with those. And then each of your relays, and there's a 6-channel relay because it has 6 of them, even though at first we're only going to be using 3 6-channel relays. Each relay has basically a common line where it's COM and then NC1 and then NO1. And so those stand for normally closed and normally open. The 1 is which relay it is. So that's relay 1, relay 2, relay 3, 4, 5, and 6. And you'll see the terminals up at the top will have N, right? Yeah. Oh, it's upside down. So we have N1, N2, N3, 4, 5, and 6. So they are matching where they go. To make it easier for me, I'm gonna go ahead and label these guys so we don't get confused, or I don't get confused. So normally open, or we have NO. Normally open means basically the circuit is not complete, it's open. The circuit completes when it's closed, so it has a closed loop. In other words, if we're thinking about it this way, where let's say my red is supplying power, I have a switch in the middle, which is imaginary right now, and then the other line connects the circuit. Normally open would be like this, so they're not touching and they can't transfer power to each other, electricity. When it's normally closed, that means it's usually going to be on. We're going to use normally open. I'm sorry, trying to complete my example here. All right. That would be normally closed, which is a little counterintuitive when we think about things like switches and stuff like that. But normally open is going to be off, and then normally closed is going to be on, or closed is going to be on, open is going to be off. And for us, we're going to be using normally open, so that's off, and we're going to close the switch to, or close the loop to get power to everything. Yeah, and then so our shield, some of these pins do not send power out like we would want them to, or they're already pre-linked to parts of the board. We're going to be using 1, 2, and 13. The reason I chose those is technically 0, 1, and 2 are great pins to use. And if you look at the actual micro bit, you can see on here 0, 1, and 2. And if we used alligator clips, we could clip them on. What many people fail to see sometimes is these very small slivers of copper that are cut. These are actually the other pins that our board is allowing us, our shield is allowing us to access. So when we put this in here, it then divides out all those tiny ones into all of these terminals so we can use, which makes it pretty easy for us to do. Yeah, so again, I'm gonna use 1, 2, and 13. The reason I chose those is because we labeled our outlet 1, 2, 3, 4, 5, 6, and not 0, 1, 2, 3, 4, 5. And so since we've done 1, 2, 3, I'm gonna do 1, 2, and 13. 3 actually controls one of the LED columns here. And if I were to use another one, I would pick 14 as 4 and not use 4. So I'm gonna connect first the shield to the relay, and I'm gonna show you how to do that. All right, so I've repositioned the camera. We're gonna continue along. What I do wanna do is first change this jumper configuration down here. These yellow jumpers. Basically, this is controlling our voltage, and I wanna shift everything to a 5 volt. So if you notice, we have one set of jumpers that's set here. I probably should use that screwdriver. That would be smart. All right, so now it's gonna be positioning. All right, so this jumper right here is the V2 jumper, and it is positioned over here where I would have 3 volts or 3.3 volts. But the V1 jumper is over here, and it's positioned where I have 5 volts. And so all I'm gonna do is take this jumper off and shift it over. So it's gonna be over here. And so to do this, I can use my hand, nail, get it under there. I could also use the screwdriver and the flathead and probably pop it up just be careful not to damage those pins. And so I have my yellow jumper here. I'm gonna shift that over and put it right back on, so they're right beside each other. There we go. And so that's what it looks like now. Both of them towards the 5-volt connection, and there we go. Next thing we're gonna do is gonna prepare our wires. I have 3 yellow wires because I'm gonna connect 3 outlets. I have 2, well, I'm sorry, I have a black, oh, maybe we should do it the other way. All right, so I've repositioned the camera. We're gonna continue along. What I do wanna do is first change this jumper configuration down here. These yellow jumpers. Basically, this is controlling our voltage, and I wanna shift everything to a 5-volt. So if you notice, we have one set of jumpers that's set here. I probably should use that screwdriver. That would be smart. All right, so now it's gonna be positioning. All right, so this jumper right here is the V2 jumper, and it is positioned over here where I would have 3 volts or 3.3 volts. But the V1 jumper is over here, and it's positioned where I have 5 volts. And so all I'm gonna do is take this jumper off and shift it over. So it's gonna be over here. And so to do this, I can use my hand, nail, get it under there. I could also use the screwdriver and the flathead and probably pop it up. Just be careful not to damage those pins. And so I have my yellow jumper here. I'm gonna shift that over and put it right back on, so they're right beside each other. There we go. And so that's what it looks like now. Both of them towards the 5-volt connection, and there we go. Next thing we're gonna do is gonna prepare our wires. So I'm preparing my wires now. I'm using 3 yellow wires that I'll show here. See where my frame is again. 1 black wire and 1 red wire. The 3 yellow wires are actually going to carry our signal to our relays to tell on and off. Our black wire is going to carry our ground, and then our red wire is going to carry the power, because we're now in DC voltage, so that's going to look a little differently. What we want to make sure is for our wires is we have the yellow wires to have 3 female ends. If need be, choose a different color, but we do need 3 female ends for what we'll consider our yellow wires. And then male ends are going to make it easier. And again, male ends look like this, female ends look like this. I do not like that they're called male and female, but we can get into gendered electronic component naming later. So what I did here with this one, because I did not have another male end, is I just cut it and then stripped it. When I used my wire strippers, which are right here, I think this one I used where it said strand 2224, that tiniest one that helps me get the vinyl or plastic off. And so I'm left with 3 yellow wires, all with female end on one side and the male end on the other. I also have my black wire, which again, same thing, male end, female end, or sorry, female end, male end, and then same thing with the red wire. So as I mentioned, our shield, what we're going to be using are pins 1, 2, and 13. And so we're going to start there. So when I pull power, I don't really need to worry about which one I'm pulling power from. I just need to pull power. So let's see if I can position this in a way. Okay, nope, that's it. So let's go ahead. We're going to connect our yellow wires first. And so I'm taking the female end and I'm going to 1 here, and it just slides down on that pin all the way. Same thing on the next one, on 2, slides down all the way. And then over on the other side, we have 13, again, the yellow right here. And just for that close up, yellow side, 1, 2, and 13. Now with my red and black, I'm gonna do black just where my 1 is, that's fine. We're just trying to get power over to our relay, and it's gonna pull that voltage. So I connect black and red in their respective pins, and this is what we got. So from here, we're gonna go over to our relay board, and what we need to do is with our screwdriver, put a flathead bit in. So see flathead bit here, and I've already done it, but I want us to show, we're gonna loosen that DC plus, DC minus, and then in 1, 2, and 3, oops, and 1, 2, and 3. That's where we're gonna be connecting these yellow wires. Apparently I was not in frame there. The plus, oh yeah, I was. In 1, 2, and 3, and we're gonna connect those here. So what I need to do is I'll start with my yellow wires. I'm gonna put my yellow 1 into N1. And this wire's pretty thin, but where I put it is, if you notice on the side, it's like an open mouth, little open mouth here. Right there, that little open mouth. That's where I'm putting this wire. I've actually stripped a little too much, but that's okay. These wires are pretty frail or bendable, malleable. I think that's the word. I'm gonna go ahead and bend that. So it's like a little loop, and then I'm gonna stick it in to 1. And oops, I'll make sure it's all in there. Oops, stuck in the wrong spot. All right, there we go. There, let's do 2. Now 2, a little easier. It has this metal clip or metal part sticking out. So I'm just gonna stick that in. 2, and put it in the mouth. Come on. There we go. In the mouth. I'm gonna tighten that up. Remember, righty tighty, lefty loosey. So when I'm tightening these screws, I should get it to the point where it holds that in place. And then 13, we're gonna do the same thing. I'm gonna put 13 and 3. Just slide 13 right there in 3. Tighten that up. All right. Next, we want to do our positive and negative. We're going to do red as positive and then black as negative. I think that's right. And I'm going to confirm before I turn it on, and I will let us know if we need to change that. But for now, let's just go ahead and do red and positive and then black and negative. So same thing, I insert that metal piece here, tighten it up. And then black as well. Now it's important, and it kind of goes without saying, but just in case, we do not want any power connected to any device while we're working on it. That can be very dangerous. Even dealing with DC voltage, we can still get a little shock. May not be too painful, but it would still not be comfortable. and we don't have any power connected to any of these components. My power that's gonna power the shield and my microbit is actually gonna go here. It's the 9-volt adapter that we got with the kit. And so now we have our connections done here. I'm gonna show that. And let everybody in. Just a little tug on everyone just to make sure everyone's there. And it looks like we're good. Next, we're gonna go ahead and connect in these parts. And this is where we're connecting it to our outlet strip, power strip. There we go, all right? In this part, we're gonna be connecting our relay here to our power strip. One thing that I forgot to do, but realized I needed to do, is I'm numbering my relay. So 1 through 6 here. We're only gonna use 1 through 3 right now. And I've loosened the screws for the terminals here for where it says NO1 and then COM1 or common 1. So that's what I've loosened on all of these 3. And so we have those loose. The other thing we need to do is, and I went ahead and prepared it, we need to cut 3 small wires, and I would say these are probably about 6 inches, maybe 5, or yeah, about 5 inches. And then strip both sides, twisting the ends so we can make sure we have a good, good strand together. And so I'm gonna shift my relay and microbit out of the way and look at my outlet. Since we are dealing with the wire part, I have unplugged my outlet to make sure that I remain safe and don't inadvertently electrocute myself. What I'm gonna end up doing is I'm gonna take this red wire, which supplies our power, and I'm gonna connect it to these 3 red wires. So we'll have power, and this will be what we use for our common. So that goes in that COM and then number, but we need that for each one of those. All right, so for our next step, what we're gonna do is we're gonna take our red wires that we have, our 3 short red wires that we have stripped on both ends, and we're gonna go ahead and twist those ends together on one side. So I'm twisting those ends. And like I said before, it probably would be best if you went ahead and twisted the end like I did for these. And so now I have all 3 of these twisted. It doesn't have to be perfect. We just need it to basically be able to fit in this yellow insulator sleeve. And that's what we're gonna do. So we're gonna wiggle this in, and we want it at least past, we want the red to at least touch the yellow, but we'd like to get it just a tiny bit more if we can. And so that's where I am on this connection. And now remember, we're doing this so we can take the red connection from our outlet and connect it here. So I'm gonna take off the little protector sleeve that I put on there, and I'm gonna go ahead and just put that right in with the other ones. Now, we didn't get a chance to bend these together, but that's okay. We can just set it here, and we're gonna use our heat gun again to solder them together. So, oop, I need to pull that a little bit back. And there we go. And so as we see that silver that is now interlaced with our copper. That means our solder has melted. I do like to try to twist the wire a little bit, not twist, turn the wire a little bit as I am, anytime I'm using the heat gun, just so I can try to get all the parts fairly evenly, but it usually doesn't happen. So no worries if you do or you don't. From this point, what I'm gonna do is, these are my common wires now. So what that means is these are the ones that are gonna be supplying the power, and we're gonna go ahead and put these into 1, 2, and 3. So here I have my, on each relay, you can see we have NC1, we have COM1, which is common 1, and then we have NO1, which again is normally open. Those are the two that I'm going to be using, common and normally open, for each of 1, 2, and 3. I went ahead and loosened my screws here, so that way I can go ahead and try to fit these wires inside. And so what I've found is sometimes they can be reluctant to go in, start having it fray and like push apart. I found either you can try to flatten this a little bit so that way it works its way in. So here, I'm gonna try to flatten it a little bit and try to go into that common. The other one is just taking a screwdriver and widening that space just slightly. And so that's what I'm gonna do. I'm gonna widen it just slightly. All right, so I have my screwdriver, a small flathead on there as a bit, one that fits right in there. And all I'm gonna do is just put it in and kind of like lever it up a tiny bit. That way the little mouth opening opens just a tiny bit more. I don't go too hard on it. I just try to get just the mouth opening just a tiny bit more so I can get that wire in there. And try to tighten it back up, and we'll go straight in. There we go. Sometimes it helps to just twist and push it in. When it's in good enough, we want to go ahead and tighten that screw back down that we have on top. So here, tightening it. Now, when I tightened it, it actually pushed it a little out, and I'm not really comfortable with that. So I'm gonna go ahead and unscrew this. And let me try to go a little bit further up. That way maybe I can get some more space in there. So now I actually have the screw a little bit above where the blue is. Let's see if that allows me to get this wire in there a little bit better. Yeah, it actually does. So I'm gonna loosen that a tiny bit more. All right, that's as much as it goes. I'm gonna widen this like I did before. And we're gonna get this wire in this time. And be good with it. Yeah, that helped quite a bit. Still not going in really great. What I'm gonna do is, what's gonna end up happening, I think, is I'm gonna have too much copper protruding out from the relay. And so I'm gonna cut a little bit off using my my cutters here. And so you see I'm down to that much, not very much at all, maybe 1/4 of an inch that I cut off. I just wanna make sure I have a nice safe thing going on. And yeah, that's looking a lot better. I'll show you after I tighten this, but I feel much better about this one. All right, tighten that screw all the way back down. And there we go. So that's what it ends up looking like. It's pretty snug in there now. Tightened it down. I'm gonna do those to the others. I'm gonna save some camera time since I showed you that one. All right, so I've connected the rest of these wires in here, tightened those screws and made them snug. Next thing we're gonna do is connect our black wires. So we have our black wires here, 1, 2, 3, and 4. I'm only gonna connect 1, 2, and 3 for now. Actually, no, sorry. I'm gonna go ahead and connect 4. We're not gonna use 4, but it's better to go ahead and have that somewhere safe than just hanging about. So gonna do the same thing, but what we're doing now, and I'm just gonna remove these little protectors that I had on here, is I'm gonna take this black wire from 1 and it's gonna go for relay 1. Now, if we wanted the switch to always stay on, and then, you know, if we send a signal to basically turn it off, then we would go and put it in normally closed. So in other words, normally on. Since our pumps are gonna usually stay off, we're gonna stick with normally open, which is the NO1. Now, something like the light, doesn't matter. Maybe normally open or normally closed, but for consistency's sake, I'm just gonna put all of them on normally open, and then that way we can make sure we have just consistency across the board. So again, to save camera time, and sorry, just to highlight, I don't have much room on my camera as I'm filming these. That they're on my phone, and so I've found that I need to explain things and then turn off the camera, let you guys do stuff, let me do stuff, and then go back on the camera. So I'm going to be connecting 1, 2, 3, and 4 to my relay from my outlet, or from my power strip. So I have all the wires connected here except 4. I wanted to show something on 4. I actually found that if you untwist and have it basically everything going the same direction, and then maybe just trim the ends that are uneven, it actually goes into the terminal a lot easier. So here I am slicing. That's like I got a little haircut, and I'm gonna put that right in. You do have to kind of position it a little bit, but it goes in a lot easier, a lot less tension. Still do need to widen this slightly, and they slide right in, which is pretty nice. So I'm gonna tighten this down. Now, if we did want to make relay 4 operational, we would need to run power or a common line to it, which would involve us either breaking this connection, which I would not recommend, or finding a way to daisy chain from one of the other ones to 4. Either way, outside of scope of this project, so we're not gonna worry too much about that. All right, so in the last section, we connected our power relay, got that wired up, as well as that 4, which is inoperable right now, but can be operable in the future. We have the other parts of our relay finished up. In this last portion of this building part, we're gonna go ahead and do the water sensor. So the water sensor should have came in your sensor box, which you can check out all of the other sensors in there and maybe start brainstorming some ideas. This little booklet they have details what each sensor is. And the cool thing is they have little projects. Now, the projects are just simply ideas of the projects, and they show you how to do them, but it's not in a very detailed form. I found them very useful when I start thinking of ideas to do. And I'm really interested in this guy, which is, let's see, what do they call it? The 4-digit LED display, because I think this could be potentially used to keep time for the microbit, and so we can do some timing stuff with it. So I'm gonna investigate that. I'm gonna take all these sensors with me, I think, to Vegas to try to figure out some stuff in some of the downtime or conferences. So what we're gonna need is, like I said, we have our water level sensor here. We have, I just pulled 2 female end jumper cables, doesn't matter what you got. I did the set with green because I can remember green means ground, and on my microbit shield I have a G, V1, and S, so I'm gonna do green for G. And luckily on Key Studio sensors, they also do the same thing on the sensors. So you see G, V, and S here, so I can remember which one to connect to. The other thing that we're gonna need, and this wasn't included, is a little pill bottle or something else that you can put your sensor in. Basically what this does is it allows our sensor to not have any weird connections with like the rocks or anything else in there, and it's just getting the water level. So here I found it's really perfect size to contain the sensor. We are gonna have to modify this, and that's why I have my drill back out. And that's what we're gonna do first. Basically, I'm gonna put 2 holes in the bottom and 1 hole in the cap. Reason I do that is the 2 holes can allow the water to come in, and the hole in the cap is where I can put my wires through and then seal it back up. So I'm gonna do that real quick. What I did is I just grabbed the biggest drill bit from my drill set, and I'm gonna go ahead and load that in. Remember, we go this way, and then keep turning it until it tightens up. Didn't even realize on there that it has the words release, so it shows you which way to turn this first part to release the bit. And opposite way is gonna be to tighten. So I wanna make sure I have my forward, so on my right side of the drill, and now I can drill my holes. So very carefully, and really and truly, you probably don't even have to do 2 holes, you can just do 1 hole right in the center, which I think I'm gonna just do 1 hole right in the center. That way, nothing too complicated. Ooh, there we go. Got that hole in there. Clean up the edges. Good, we're gonna do the same thing for the cap. Drill right in the center here. And clean up the edges. There we go. We'll make sure we get all these little bits of plastic out of the way. And now, when I'm connecting my jumpers to my sensor, I'm gonna go ahead and, like I said, green for ground. And on my sensor, I have a G here. I'm gonna go ahead and connect that. Just putting it in that way, and whatever's next to it, I'm just gonna put next to it. So for me, the blue is becoming volt, and then this purple is becoming signal. So now I have it connected, just like this. And I'm gonna use pin 0. So on my board here, I know it's gonna get a little crowded on this side, but I'm gonna use pin 0 right here. I'm gonna connect my green to ground on my shield, and then blue to volt. And purple to signal. Now, you notice there's not much length here. Very small amount of length actually, and I don't know, depending on how far away it's actually gonna fit. So you can daisy chain these together. And so if you take some of the ones that are male, you can do that, simply plugging it in. So here, if I took, same colors. I can do green, blue, and purple. And I would secure that with some tape. electrical tape if you have it, duct tape if you don't. And so there we go, daisy chained together. And now I can connect my sensor back. I'm actually gonna keep it this way. Now, what we wanna do though is pass the wires through the cap first. That way we're able to actually get our connection. And what I did is I just passed 2 through first, and then the third one, now I can connect. So green to ground, then blue, then purple, and I can put that right back in my thing. I'll go ahead and turn it, and we have our little water sensor. And so what we're gonna do with that, I'm gonna turn the camera, I have it set up right here, try to get some more. And so I can just bury this in the rocks. And what I've been doing is our marks we had before, if you notice those little black marks around the side, I accidentally yanked my pump out on moving stuff. But I'm just gonna put my my sensor, basically dig down, and I'm gonna put it where those marks are. So the top of the cap, sorry about this, top of the cap, down to those. There we go. All right, so just to show here, you see I put cap down to those lines. We have our wires coming out, and we can put the expanded clay back around it. Basically, that sensor is going to allow us to pump water in until a certain point, and that certain point we can turn off the pump. And so I will show you guys how to do that when we look at the programming part. But you have, at this point, a fully built HydroBitBox. You just have to program it, and that's what we're gonna do.